Hello everyone, welcome to this MOOC session. I am Professor Amit Kumar Yadav, and in today's session we will going to cover the various components under Encyclopedia of Electrical and Electronic Component. So in this topic we will cover various types of component which we normally use in our electrical and electronic domain. So today our topic will be battery, which is very important and essential component of electrical and electronic domain. Okay, so let's move ahead. A battery contains one or more electrochemical cell in which chemical reaction create an electrical potential between two emerged cells. In this figure, you can see here, we have a multiple number of batteries, and in battery, basically, chemical reaction take place, and in the battery, through this chemical reaction, we will get a potential at two terminals in the battery. Now, here is the systematic symbol of the battery. In this diagram, you can see, if you see this first block, here we have a systematic symbol of cell. Here, this bigger line shows the positive terminal, and this bold, smaller line shows the negative terminal. And when we connect with numbers of cells, suppose if we connect two cells together in series, then it will create a battery. Okay, so this second block shows the systematic symbol of battery. And if we have to make any arrangement like such battery connection, in which you can see here we used various numbers of battery connected in series or parallel. In that case, we will represent this type of battery connection through the system, through this systematic symbol. Here, this dot line shows the multiple of number of batteries connected together. Okay. And in this diagram, you can see here, this first block shows a single cell. And in single cell, we are getting output of 1.4 volt, and its battery capacity is 2 ampere hour. But if you have to connect the cells in series connection, then how you will do that? For connecting these battery in series, we use this systematic diagram. Here you can see that here positive is connected in series with negative, and the positive of the second battery is again connected with the negative of the third battery. The positive of the third battery is connected with the negative of the fourth battery. So in this way, we will connect the various cells together for getting a series connection. Okay, so why we do the series connection? By doing the series connection, we just add on the voltage of all the cells. Here, the voltage of one cell is 1.5 volt, and by connecting the four cells together in the series, we get an output of 6 volt. But here, the battery capacity is same. For example, if we have to maintain a constant voltage, but if we have to increase the battery capacity, then what we will do? Then in that case, we will connect all the battery in the parallel. Look here, we have connected these four battery of 1.4 volt in parallel. Then what will happen to this connection? Here, we get 1.5 volt, but here the battery capacity of a single cell, which is 2 ampere hour, will now get changed to 8 ampere hour. So in this way, if you have to suppose increase the battery capacity, then you will have to do the parallel connection. And suppose if we have to take the higher voltage, if you suppose have to get the higher voltage, then you just do the series connection of all the battery. Okay. Now next is a variant of battery. Basically, battery have two variants. First one is your disposable battery. So this diagram, you can easily identify how the disposable battery look like. Normally, what is disposable battery? It's as its name suggests, basically these are the battery which we cannot recharge again. Okay, these battery can be used only once. After getting discharging, we cannot use it again. Okay, so that's why they are called as dischargeable battery. Here we have a 9-volt transistor battery. Here we have 1.4-volt battery cell, pencil cell. Okay, and these two battery are disposable battery, and they are your zinc carbon and alkaline cells. Now, the second category of the battery variant is your rechargeable battery. As its name suggests, these batteries are rechargeable. It means you can recharge this battery again and again. Okay, but up to a certain time, this battery does not have recharging capacity, but you can recharge it again and again up to a certain time period. Okay, so what are the various category of the rechargeable battery? Basically, rechargeable battery can be of your lead acid, nickel, cadmium, which is abbreviated as NiCad or NiCd. And another type is your nickel metal hydride. Also, it's also a very important type of rechargeable battery, which is abbreviated as NiMH. And the most important in the current scenario, the most important battery is your lithium ion battery. These are very famous battery in the EV technology or in battery, or if anywhere where we required a high specific energy from the battery, then we normally prefer the lithium ion battery. Okay. Here in this picture, you can see some types of rechargeable battery. This top left battery is your battery pack of the nickel cadmium battery, which is basically used as a cordless phone. Here in the top right, we have this most famous lithium battery, which we normally use in digital camera. And in the bottom, we have this nickel metal hydride battery. Okay. Now moving ahead to next point, capacity. This is a very important topic of, this is a very important part of this our topic, capacity. How do we calculate the capacity of any battery? So in this topic, we will basically cover the how we can calculate the capacity of the battery. The electrical capacity of a battery is normally measured in ampere hour, which we normally abbreviated as AH. You can also write it as capital AH, or you can also write it as A/H. The smaller the value, if you have to measure any smaller value of the battery, then we can use this milliampere term also, which is abbreviated as a small m, capital A, small h. MAH. Okay, so how do we calculate the capacity of the battery? Suppose if we draw I current, if I is the current which we drawn from any battery, and T is the time for which we get that current, then the battery will deliver, in that case, the ampere hour capacity of the battery will be current into time. So this is a general formula for calculating the capacity of the battery. Here, this AH is denoting its capacity. Here, I is the current of the battery, which we drawn from it, and T is the time for which we get the current from the battery. Now, go through a simple calculation. Now, by using this conventional method, let's take an example of lead acid battery, and the battery capacity of that lead acid battery is suppose 4Ah, and the current we drawn from that battery is suppose 5 ampere. So by using that conventional formula, how much the time for which this battery will deliver the 5 ampere current, for that, we will use the formula AH upon I, where AH, the value of AH is your ampere hour and its value is 4, and here I is 5. So if you solve this, you will get that this battery will give a 5 ampere of output constantly for 48 minutes. For 48 minutes. But this conventional method is not always correct. If you have to calculate a rough value of time for which the battery will give that particular output, then you can use that conventional formula. But suppose if you want to calculate this battery capacity, time duration of that battery capacity for any device, for example, EV, where we required a precise and correct battery capacity, then in that case, that formula will not be good. Okay, so in reality, this conveniently linear relationship does not exist. It could break down as the current rises, especially when using lead acid battery, which do not perform well when required to deliver high current. Then what is the solution? So to overcome from this problem, we normally use a Peugeot number. Okay, this Peugeot number is named after the German originator in 1897, and in this Peugeot number, basically manufacturer give you a value of a small n. This Peugeot numbers have a value of a small n, which normally any battery manufacturer provide you. Okay, so in the previous formula, there is a modification. After doing a small modification in the previous formula, the new formula for calculating the battery capacity is here T equals to AH upon I to the power n, where this n is your Peugeot number, which is normally provided by the battery suppliers of every type of battery category. Okay, so here T is the time period for which this battery will give you that high much of current. Okay, so suppose if we use this formula, let's do another numerical calculation. Now, by using this Peugeot number, suppose we are using the lead acid battery and the supplier have given the Peugeot number and the value of here n is 1.2. Okay, so by using this Peugeot number, there is a small modification in the formula. Here, in place of I, we will use I to the power n, where n is your Peugeot number, which is supplied by the battery manufacturer. So in case of suppose lead acid battery, suppose here we are taking the case of lead acid battery, where n is 1.2. So if you put this value of 1.2 in place of n here, so you will get that when we have the same battery of 4Ah, which we have already taken in your previous conventional method, and the current drawn from the battery is again 5 here. In previous method, it is also 5 ampere. So by using the new modified formula, not modified, it's a Peugeot modified formula, Peugeot method, you can say that. Then the time period, or you can say the out time for which the battery will give this 5 ampere current is now come to the 35 minutes. And in previous formula, it is your 48 minutes. So again, there is a big difference. Okay. Calculation. Now this Peugeot method have a problem. Okay. In Peugeot method, we normally, in Peugeot method, the ampere hour rating for a battery was established by a manufacturer by drawing a constant of one current and measuring the time during which the battery was capable of delivering that current. If suppose we took 4 hours, suppose if to take 4 hours, then we normally rate that battery as a 4 ampere hour. Okay, but this method is also not too exact for calculating the battery capacity. So today, this measurement process is reversed. Instead of specifying the current to be drawn from the battery, a manufacturer specifies the time for which the test will run. then find the maximum current the battery can deliver for that time. Often we do this normally for 20 hours in our modern method. So the modern method of calculating the battery output giving capacity, here we use this formula where this H is provided by the battery manufacturer. Here this H is basically your 20 hour. That means the time period for which you are going to conduct this experiment, which is it basically this H denotes the time period for which you are going to test your battery. And here AHM is the modern battery output, and I is the current which we are going to draw from that battery, and here N is the Peugeot number. And current scenario, basically the battery manufacturer provide two data with the battery. First one is the C rate, and what is C rate? Basically the reciprocal of C rates denotes the value of H. And second data which provide the manufacturer is your small n, that is a Peugeot number. So by using this formula, now let's do a small calculation by using this formula to calculate the time for which we get this battery capacity with this constant current value. Okay, let's do it. So by using the modern method, we have this formula, and for that modern method, we have the battery capacity of 4H, current is again 5A, Peugeot number is 1.2, and by putting all these values in this modern formula, we get that battery time period of 25 minutes, which is the most accurate formula. In the conventional method, you have seen that we get a 48 minute, and this conventional formula, we can use this conventional formula for the rough calculation of the battery. But if you want to calculate the exact battery time period, then you have to use this modern method. So with this, I'm going to end this lecture. Please provide your valuable feedbacks so that we can improve our topic and content of delivery. Okay, thank you so much for watching this video. Thank you.